In the immortal words of Carl Sagan, we are star stuff. What he meant is the key elements of life were forged in the hearts of stars. The iron that turns our blood red, the oxygen that fills our lungs, the carbon that gives infinite variety to organic compounds, they were all cooked up in a stellar inferno billions of years ago. So, when researchers recently got a look at a star turned inside out, they knew they were looking at the stuff of life itself. The story begins just after the Big Bang 13.7 billion years ago. According to modern cosmology, the newborn universe was made entirely of the three simplest atoms, hydrogen, helium, and small amounts of lithium. The cosmos was devoid of stars, and very likely devoid of life as well. A quick glance around the room is proof that times have changed. Light elements that filled the early universe are rare on Earth, while our planet and we ourselves consist mainly of heavier stuff like oxygen and carbon, which were missing at the dawn of cosmic history. The difference is star formation. A little more than 13 billion years ago, the first stars collapsed from clouds of hydrogen and helium. As gravity drew the gas inward, temperatures reached levels that triggered nuclear fusion, the same process that powers our sun today. In a stellar fusion reactor, hydrogen and helium are smashed together to build up heavier elements, such as carbon, nitrogen, oxygen, and iron. Since then, heavy elements have been forming in stars throughout the universe. Supernova explosions presumably did the rest, flinging their contents far and wide, seeding galaxies with the atomic building blocks of life. Recent data from NASA's Chandra X-ray Observatory provide dramatic confirmation for this idea. Researchers Una Huang of the Goddard Space Flight Center and John Lamming of the Naval Research Laboratory used Chandra to map elements in the debris of a supernova known as Cassiopeia A, Cas-A for short. Cas-A is located about 11,000 light-years from Earth. The original star, a behemoth at least 15 times as massive as the Sun, exploded more than 300 years ago. Hot glowing debris from the explosion is still visible, and a favorite target of astronomers who study supernovas. The researchers scanned Cas-A using Chandra's advanced CCD imaging spectrometer. This revealed concentrations of iron, sulfur, silicon, magnesium, neon, and oxygen. Comparing a chemical model of the original star to the actual distribution of elements seen today, they realized something amazing. When the star exploded, it turned itself inside out. Most of the iron, which originally formed deep inside of the star, is now located near the outer edges of the debris cloud. Other heavy elements are also located at the outer limits of the debris zone. These data show that elements cooked deep inside stars are not necessarily trapped inside. Supernova explosions can free them, spewing core materials into deep space. There, the atoms of life intermingle with other interstellar atoms and molecules, forming clouds of gas that collapse to form new stars, new planets, and maybe, just maybe, new life forms. We are star stuff, after all.